Let's discuss the parametric form of a circle. So here in this particular diagram, we have the coordinate axis and we have a circle which is centered at the origin. Any circle which is centered at the origin, its equation will be given by x squared plus y squared equals to r squared, where r is the radius of the circle. So what we'll do, we'll consider a point P on the circle. Let's say the point P has the coordinates x1 comma y1. Fine. Then what we'll do, we'll drop a perpendicular from point P on the x-axis. Let's say PM is the perpendicular drawn on the x-axis, and we draw another perpendicular PN on the y-axis. And we are also going to join point O and point P, and this is nothing but the radius of a circle. The line OP, or the radius of the circle, is making an angle theta with the positive x-axis. Now clearly in triangle OPM, we can define the sine of angle theta. This will be equals to, the sine theta is given by the opposite, which is PM, over the hypotenuse, which is OP. So PM will be equals to OP sine theta. Now what's OP? OP is nothing but the radius of the circle. So PM, this is equals to R times sine theta. And we can also define the cosine of angle theta. So that's going to be the base, which is OM, divided by the hypotenuse OM, meaning OM will be equals to OP times cosine theta. OP being the radius, we get R cosine theta. Now clearly from diagram, OM, it's nothing but the x coordinate of point P, which is considered as x1. And then we have PM. PM is the y coordinate of point P, so that means y1 will be equals to r sine theta. However, if we want to generalize this, then we can say x will be parameterized to give us r cosine theta, y will parameterize to give us r sine theta. So this is called the parametric form of the circle, where we have represented the point, any point lying on the circle, by its parametric form, where x will be given by r cosine theta and y will be given by r sine theta. Now we can check it out. If we square x as well as square y and add them, then x squared plus y squared is going to give back r squared. For instance, let us consider a circle given by, let's say this is example number 1. We have a circle with the equation given by x squared plus y squared equals to 25. Now clearly, this is a circle which is centered at the origin. That means the center will have a coordinate 0, 0, and the radius will be simply equals to square root of 25, and this is the value 5. That means the circle has a radius of 5 units. Then if we parameterize the x and the y value, then x will be equals to r times cosine theta. Is simply replacing the value of r with 5, we're going to get 5 cosine theta. Then we're going to parameterize y as well. The y is given by r times sine theta. Replacing the value of r with 5, we get 5 sine theta. So here we have successfully parameterized the circle having the equation x squared plus y squared equals to 25. However, in this case, we consider that our center is at the origin. Now what if the center is not at the origin? Then how will the parametric form of the circle is going to look like? So let's do that. So this time we're going to consider a circle with center C with coordinates h comma k. So this is not having a center at the origin, but with coordinates h comma k. Now there is a point P that we are going to consider on the circle with coordinates x comma y. Now we know that the equation of a circle whose coordinates of the center are at h comma k is given by x minus h whole squared plus y minus k whole squared equals to the square of the radius. The quick way to remember this particular formula is you can join point C and point P. That's nothing but the radius of the circle, and if you use the distance formula, then the distance r will be equals to the square root of the square of the difference of the x coordinate. That's why we are having here x minus h whole squared added to the square of the difference of the y coordinate, which is y minus k whole squared. To get rid of the square root, we are squaring both sides. So this gives us the equation of the circle which center has the coordinates h comma k. Now what we'll do, from point P, we're going to drop a perpendicular on the x-axis. So we have the perpendicular PM on the x-axis. Similarly, we're going to drop a perpendicular from point C on the x-axis as well. We have CN perpendicular on the x-axis, and then we're going to drop a perpendicular from the center C on the line PM. Let's say it meets at the point D. Now we have this angle theta, and theta is the angle made by CD with the radius CP of the circle. Now clearly we can define the coordinates of point P. So coordinates of point P, which is nothing but the x coordinate, will be given by, so to define the x coordinate, we have this particular distance of the center from the y-axis, which is nothing but the h value, added to now CD, added to CD. And to find out the y coordinate, we have the height k, and to it we are going to add PD. Now we can define CD and PD for the triangle. So let's consider the right angle triangle CDP, which is right angle at D. We can define cosine of angle theta, and we can define sine of angle theta. So cosine of angle theta, that's going to be CD over CP, which means that CD is going to be equals to CP cosine theta. Now what's CP? CP is nothing but the radius of the circle, that's r cosine theta. Similarly, sine theta, we can define it as the ratio of the opposite, that's PD, to that of the hypotenuse, CP. So PD is going to be equals to CP sine theta, CP being the radius of the circle, we get r sine theta. Now we can replace the value of CD with r cosine theta. So this gives us the x coordinate of point P, so that's going to be h plus r cosine theta. And the y coordinate is going to be y equals to, so here we have k plus r sine theta. So that means we have parameterized the x and the y value. So that parameterization means we have represent x coordinate and the y coordinate of the point P of any point that lies in the circle in terms of a parameter theta. Fine. So let's try to understand this with the help of a problem. Let's suppose we have a circle whose equation is given by, we're going to do example number 2. The equation of the circle is given by x squared plus y squared minus 2x minus 4y minus 4 equals to 0. Okay, so let's try to simplify this equation. So here we have x squared minus 2x added to y squared minus 4y. We're going to transpose this negative 4 to the right hand side to get 4. Now we're going to make x squared minus 2x a perfect square. For this, what we'll do x squared minus 2x. To it we are going to add 1 and subtract 1 from it. This is an extra term that we are adding and subtracting. Then we are also going to make y squared minus 4y a perfect square. For this we are going to add 4 and subtract 4 from it. This will be equals to 4. Now x squared minus 2x plus 1, that's nothing but x minus 1 whole square. Then we have y squared minus 4y plus 4. This will be y minus 2 whole square. Now what we can do, we can transpose negative 1 and negative 4. So that becomes negative 5 to the right hand side combined with 4 to get 9. So that means we have x minus 1 whole squared plus y minus k y minus 2 whole squared equals to 3 squared. Now if we compare it with the form x minus h whole squared plus y minus k whole squared equals to r squared, so we get the value. So h comes out to be equals to 1, the value of k, that's going to be 2, and r is 3. That means the circle is centered at the coordinates 1, 2, and the radius is 3 units. Now we need to parameterize it. So that means x, which is given by h plus r cosine theta. So we substitute the value of h with 1 and the radius will be 3. So we have 1 plus 3 cosine theta, and for y we have k plus r sine theta. So in place of k we have 3. We have 3, k is 2. So we have 2 plus 3 times sine theta. So we have successfully parameterized the equation of a circle given by x squared plus y squared minus 2x minus 4y minus 4 equals to 0. Here the parameter theta, so it has a value lying between 0 and 2 pi.